In this part, we'll create a custom block. Click the plus button under Custom Blocks. This opens the Custom Block Editor. Here, we'll define inputs, outputs, parameters, and give the block a name and description. Let's name the block FM Demodulator. In the description, type FM Demodulator. You can choose an icon. I'll select a pre-made SVG image. It now appears next to the block's name. Set inputs and outputs. Add an input. Name it in. Set its direction to input. Add a short description. IQ stream. Choose these types: complex float 32 and complex int 16. Now add an output. Name it out. Set the type to float 32. Next, add a parameter. Name it mod index. Type float 32. Min 0, max 1, step 0.01, default 5. Mark it as required. Add code to the block. Click Edit Block Code. Insert the code template. This adds method stubs with comments as a guide. The block has the following methods: onConfigure, called when parameters change; onStart, when the app starts; onStop, when the app stops; onData, when input data arrives; onProcess, optional advanced logic. For now, leave the template unchanged. It logs method calls to the console. Let's test the block. Insert the block into the diagram. Now drag the FM Demodulator into the flow. Connect. Resampler, FM Demodulator, frequency sync. We'll use the default mod index value. Check the console, press F12 to open the debugger. Go to the console tab. You should see Start Event, the app, Data Event, Input is active. We also see an input array of type float 32, length 16384. That's 8,192 IQ samples. Each sample equals 2 float 32 values. Below it, we see the output array. Now write the actual demodulator code. Go back to the block panel. Hover over the custom block. Click Edit. Click Edit Block Code. Step 1. onConfigure. Handle the mod index parameter. Step 2. onStart, initialize a variable to store the previous IQ sample. Step 3. onData, comment out the log line to reduce CPU usage. Now let's process the incoming data. Each packet includes a header with flags overrun count and timestamp, a data array, actual sample values. For complex input, each sample equals 2 numbers, I and Q, stored one after the other. Let's make sure input and output arrays exist. Get a local reference to input data. Name it inIQ. Divide its length by 2 to get the number of samples. Use bit shift for that. Make sure the output array is sized properly. If not, allocate a new buffer. Now create a reference to output data. Name it out. FM demodulation. Each IQ sample is a complex number, z equals I plus jq. Let z1 be the current sample and z0 the previous one. The phase difference is the angle of z1's conjugate z0. That's the FM signal. Loop through all samples. Extract I and Q. Calculate the real and imaginary parts of z1 conjugate 0. Use math.n2 to compute the phase angle. Multiply it by mod index. Store the result in the output array. Save the current sample as the new 0. Test the demodulator. Highlight a signal in the spectrum. You should see the demodulated output. Look for a 19 kHz pilot tone, a sign it's working. Fix small issues. The tune frequency field shows only an offset. Update it to show the center frequency instead. Add a missing connection to the frequency parameter on the NCO. Also, adjust the y-axis range of the frequency sync. Set it from 0 to -60 dB. Now test again. Much better. Add audio output. Drag in an audio sync block. Connect it to the output of the FM demodulator. Also connect the rate. Run the app again. And now we hear the sound. Thanks for watching. We hope this gave you a better understanding of how to build custom blocks and process signals inside the WebSDR platform. See you in the next video.